Hello everyone, welcome to the channel. So today we will be studying T network and pi network. So let's get started. T network or star network. So the T network, the impedances Z1, Z2 and Z3 in the network are arranged in a T shape. Firstly, we will talk about some terms which will be used later on. Here OC means open circuit and SC means short circuit. So Z1 OC. It is the impedance between input terminals 1-1 when output terminals 2-2 are open. Z1SC, it is the impedance between input terminals 1-1 when output terminals 2-2 are short. Z2OC, it is the impedance between output terminals when input terminals 1-1 are open. And Z2SC, it means the impedance between output terminals 2-2 when input terminals 1-1 are short. So from the definition of Z1OC, uh, output terminals 2-2 are open, then there will be no flow of current through the impedance Z2. Then Z1OC is equals to Z1 plus Z3. For the impedance Z1SC, the output terminals 2-2 are short. Then the impedance Z2 and Z3 are in parallel, which will be in series with Z1. So Z1SC will be Z1 plus Z2 Z3 by Z2 plus Z3. For the impedance Z2OC, the input terminals are open. Then there will be no flow of current through the impedance Z1. Then Z2OC is equals to Z2 plus Z3. Now for the Z2SC, the input terminals are short. Then the impedance Z1 and Z3 are in parallel, which will be in series with Z2. Then we will get this equation. Now we will subtract Z1OC and Z1SC, which will be this. Now here Z2 plus Z3 can be written as Z2OC. From that we will get this equation. From here we can write the equation for the Z3, which we will replace in the first and third equation. From that we will get Z1 and value of Z2 in the T network. Now pi network or delta network. In this network the impedances ZA, ZB and ZC are in pi shape. Now for impedance Z1OC, the output terminals 2-2 are open, in which case there will still be current flowing through the impedance ZC. Then impedance ZB and ZC are in series, which are in parallel with ZA. From that we will get this equation. Now for the impedance Z1SC, output terminals 2-2 are short, in which case the potential at point A and point B is same, in which case there will be no current flowing through the impedance ZC. Then ZA and ZB are in parallel, which will give ZA ZB by ZA plus ZB. For the impedance Z2OC, the input terminals 1-1 are open, in which case there will be current flowing through the impedance ZA, ZC and ZB. Then we will get this equation. In this, ZA and ZB are in series, which are in parallel with ZC. Now for the Z2SC, input terminals 1-1 are short, in which case the potential at point A and point B is same. Then there will be no current flowing through the impedance ZA, and ZB and ZC will be in parallel, which will give this equation. Now we will multiply Z2OC and Z1SC, from which we will get this equation, and we will subtract Z1OC and Z1SC. Upon solving this equation, we will get this equation, which we will multiply and divide by ZC. Now here, ZC, ZA plus ZB can be replaced from equation third, and we will get this. We will write it in this form. Now we will divide this equation by the equation we get from multiplying Z2OC and Z1SC, upon which we will get ZB in the denominator, which upon reversing will give us this equation, which upon substituting will give us equation for the impedance ZA and ZC. Until now, we have studied how to find the impedances for the T and pi network. Now we will study how to convert a T network into a pi network. Now, for the impedance Z1OC, output terminals 2, 2 are open, in which case there will be no flow of current through the impedance Z2. Then we will get Z1OC for the T network Z1 plus Z3. For the pi network, output terminals 2, 2 are open, but there will be current flowing through the impedance Zc. From that we will get Zb plus Zc in series, which in parallel with the impedance Za. Similarly, for the impedance Z2OC, input terminals are open. There will be no flow of current through the Z1, and we will get Z2 plus Z3 for the T network. For the pi network, 1, 1 are open, and there will be current flowing through the impedance Za. Then Za and Zb are in series, which are in parallel with Zc, which will give us this equation. As for the impedance Z12OC, one input terminal and one output terminal is open in T network, in which case there will be no flow of current to the Z3, and we will get Z1 plus Z2. For the pi network, one input terminal and one output terminal is open, in which case there will be flow of current through impedance ZB, ZA, and ZC. From that, ZA and ZC are in series, which is in parallel with ZB. So we will get this equation. Now we will be adding equation 1, 2 and 3, which will give us equation 4, Z1 plus Z2 plus Z3 is equals to ZA ZB plus ZB ZC plus ZC ZA by ZA plus ZB plus ZC. Now on subtracting, equation 4 and 1 will give us equation for impedance Z2 of T network in terms of impedance of pi network. Similarly, on subtracting equation 4 and 2 and equation 4 and 3 will give us for the impedance Z1 of T network in terms of impedances of pi network. From equation 5, 6 and 7 we can convert a pi network into a T network. That is, if we have a pi network of impedances ZA, ZB and ZC, we can convert it into a T network of impedances Z1, Z2 and Z3, and we can find the impedances of the T network from these equations. Now, if we multiply equation 5, 6 and 7 and add, we get in LHS Z1 Z2 plus Z2 Z3 plus Z3 Z1, and in RHS this equation, in which upon taking common ZA ZB ZC in numerator will give us this equation, which upon cancellation gives us 8 equations. Z1 Z2 plus Z2 Z3 plus Z3 Z1 is equals to ZA ZB ZC by ZA plus ZB plus ZC. Now, upon substitution of equation 5, 6 and 7 in 8 will give us equations for impedance ZA of pi network in terms of impedances of T network, from which we can convert a T network into a pi network. That is, if we have a T network of impedances Z1, Z2 and Z3, we can convert it into a pi network of impedances ZA, ZB and ZC, and the value of impedances from the equation 9th, 10th and 11th. That's all for today. Thank you and have a nice day.